All right, so today we're diving deep into AI and cloud computing. We've got a ton of research about how these two have become like the power couple of the enterprise tech world.
It's pretty amazing how this relationship has evolved. I mean, just a decade ago, companies were uh, struggling to train even like basic AI models, right? That
Yeah.
they were really limited by their own infrastructure.
So they needed a hero. Enter the cloud.
Yeah, exactly. Cloud computing with like its flexibility and just sheer scale, it was a perfect solution. Suddenly, even smaller companies could access this kind of computing power that was once only for like the tech giants.
Uh-huh.
That's the real game changer here, the democratization of AI.
But how has this dynamic duo like actually changed the game for businesses? What does it mean for like someone listening right now? That's what we're going to unpack today.
Yeah, we're going to explore how the cloud has gone way beyond just like providing basic computing. It's now about specialized hardware and software, tailored for AI. And then there's managing these massive data sets and even rethinking how we approach AI development and security. It's a lot.
Okay, let's start with the infrastructure. It's not just about renting servers anymore, is it?
No, not at all. Cloud providers are now offering these specialized processors, things like GPUs and Google's TPUs. These are optimized for very specific AI tasks.
GPUs, those are the things gamers obsess over, right? What makes them so special for AI?
They're amazing at parallel processing, which is absolutely crucial for training complex AI models. For example, image recognition models. Those used to take weeks to train. They can now be trained in a fraction of the time, all thanks to GPUs. This means businesses can get insights from their data so much faster, giving them a competitive edge. And then there's TPUs, which are even more specialized for AI tasks, things like natural language processing.
So it's like having like a custom-built brain in the cloud, optimized for specific AI tasks.
Yeah, that's a great way to put it. And it's not just the processors. It's high performance everything. Memory, networking, storage, all designed to handle the unique demands of AI workloads.
Give me an example. Paint a picture of what this AI-powered cloud infrastructure actually looks like.
Imagine Amazon's EC2 P4 instances. These are packed with NVIDIA A100 GPUs, some of the most powerful GPUs available, and they have petabit-scale networking, meaning they can move data around so fast. It's like having a superhighway for your AI data.
Okay, that's the brawn. But what about the brains? AI is like notoriously data hungry. How has the cloud adapted to feed this beast?
That's where data lakes and data warehouses come in. These are massive repositories for storing and managing the vast amounts of data that AI needs.
Data lakes sound kind of chaotic. Is it just a giant dump of raw data?
Yeah, you could say that, but there's like a method to the madness. Data lakes store data in its native format, no pre-processing or structuring. This makes them really flexible because you can use the same data for a bunch of different AI applications.
Yeah. And data warehouses. Those are the more organized siblings.
Exactly. Data warehouses are designed for structured and semi-structured data. They're traditionally used for business intelligence and reporting, but they're becoming much more AI friendly now.
So they're like evolving to speak the language of AI.
They are. Modern data warehouses can handle these super complex queries that AI applications require. And they can also integrate directly with machine learning platforms, which makes it easier to train and deploy models.
This is all starting to sound very complex. How do you even manage this intricate dance between, AI models, data, and all this infrastructure? It seems like a logistical nightmare.
That's where MLOps comes in. Think of it as the glue that holds it all together. It's a set of practices and tools that streamline that entire machine learning workflow, from data preparation to model deployment and monitoring.
MLOps. It's like DevOps, but for machine learning. So it's all about bringing automation and efficiency to the AI world.
Exactly. And cloud platforms are playing a crucial role in making MLOps a reality. They provide the tools and infrastructure to automate so many of those tedious tasks involved in building and deploying AI models.
Give me an example of what this automation looks like, in practice.
Imagine building a model to predict customer churn. With MLOps, you can set up an automated pipeline that pulls in new customer data, pre-processes it, trains your model, evaluates performance, and even deploys it to production, all without any manual intervention.
So it's like having an AI assembly line constantly churn out and refining models.
Yeah, that's a great analogy. And it's incredibly powerful. Frees up data scientists to focus on the more creative and strategic aspects of their work rather than getting bogged down in those manual tasks.
That's impressive, but with all these moving parts, how do you keep track of everything? It seems like it'd be so easy to lose track of which data, code, and model versions were used for what.
Right, and that's where version control comes in. Cloud-based MLOps platforms let you track every single change, from code updates to data modifications and even model parameters. Ensures reproducibility, meaning you can always go back and see exactly how a model was created and why certain decisions were made.
So it's like a time machine for your AI project. You can rewind, understand past decisions, and even reproduce results if needed.
You got it. This is crucial for collaboration, debugging, and auditing your AI systems.
Okay, we've got our automated pipelines and we're tracking everything meticulously. But what about once the model is out in the wild? How do we make sure it's still performing well? The real world is messy and unpredictable.
That's where model monitoring comes in. Cloud-based tools let you keep a constant eye on your models in real time. They can detect things like anomalies in the data, concept drift, and performance degradation.
Hold on, what's concept drift?
Oh, it's when your model's performance starts to decline, because the data it's seeing in the real world is different from the data it was trained on. Maybe customer behavior has changed, or there's a new trend emerging that your model hasn't seen before.
So the model is like getting rusty because the world is changing around it.
Exactly. And cloud-based monitoring tools can detect that rust early on so you can retrain your model with fresh data and keep it performing at its best. Azure Machine Learning is a great example of a platform that does this really well.
This all sounds amazing, but are there any downsides? What about security? With all this valuable data and powerful AI running in the cloud, aren't we just painting a giant target on our backs for hackers?
Well, security is a huge concern. You're absolutely right. But that's another area where the cloud has really stepped up. Cloud providers have invested so much in security measures to protect both data and AI models. They've had to because, the stakes are so high now.
Give me some specifics. How are they actually keeping AI safe in the cloud?
Well, encryption is fundamental. Cloud platforms encrypt data, both in transit and at rest, meaning it's protected even if someone gains access to the underlying storage or network.
So even if someone breaks in, they can't actually read the data.
That's the goal. And some platforms are even using cutting-edge techniques like homomorphic encryption, which allows computations to be performed on encrypted data without ever decrypting it.
Wait, you can do math on encrypted data? That sounds like something out of a spy movie.
It does, doesn't it? But it's becoming a reality, and it has huge implications for privacy and security in the AI world.
But what about the models themselves? Those are like valuable pieces of intellectual property. How do you protect them from being stolen or copied?
Yeah, that's where things like secure enclaves come in. These are isolated environments within the cloud where your mod can run, protected from prying eyes. Think of it like a digital vault for your AI. There are also other techniques like tokenization, where sensitive data is replaced with non-sensitive equivalents, and sophisticated attack detection systems constantly monitor for suspicious activity.
It sounds like the cloud providers are going to great lengths to keep AI secure. But with all these advantages, is there any reason not to use the cloud for AI projects these days?
Well, it does seem like the cloud is the obvious choice for most organizations. But there's another layer to this story. The rise of multi-cloud and hybrid strategies.
Wait, so you're saying there's more to the cloud than just picking one provider and calling it a day?
That's right. The world of cloud AI is much more nuanced than that. While some companies might be perfectly happy with a single cloud provider, others are finding that a multi-cloud or hybrid approach better suits their needs.
Okay, I'm intrigued. Break it down for me. What are multi-cloud and hybrid strategies? And why are they gaining traction in the AI world?
Let's start with multi-cloud. This is essentially the idea of using different cloud providers for different parts of your AI operation. It's like choosing the best tool for each job, rather than being limited to one toolbox.
So you're not putting all your eggs in one basket. That sounds pretty smart, especially if you're worried about vendor lock-in. But how do you even manage multiple cloud environments? It sounds incredibly complex.
It can be, but there are tools and platforms emerging that are designed to help organizations manage multi-cloud environments, and the benefits can be significant. Increased flexibility, resilience, and potentially even cost savings.
What about hybrid cloud? Is that just a fancy way of saying you're using both the cloud and your own data center?
That's the gist of it. It's about combining the best of both worlds. You might keep sensitive data on-premises for security or regulatory reasons, while leveraging the cloud's scalability for compute-intensive tasks like model training.
So it's all about finding the right balance.
Precisely. Multi-cloud and hybrid strategies are all about finding the right mix of cloud and on-premises resources to meet your specific needs. Welcome back. So, last time we were exploring how AI and cloud computing have become like this powerful force in the enterprise tech world.
Yeah, we talked about how the cloud is transforming everything, specialized hardware, those
Yeah.
massive data sets, even the way we develop AI.
Right, right. But before we jump into the future of AI, I think we need to talk about the players who are like shaping the present, the major cloud providers and their approaches to AI.
Yeah, that's right. We've got some research here on the key players: AWS, Google Cloud, Microsoft Azure, even IBM Cloud. It's like a superhero team up, each with their own superpowers.
It is a bit like that, yeah.
Eh,
Each provider brings their own strengths and specialties to the table.
Let's start with AWS. They've been in the cloud game longer than almost anyone. What's their AI strategy?
Well, AWS basically aims to be the one-stop shop for all your AI needs.
Hmm.
They've built this like massive ecosystem of services to support that, from raw infrastructure to pre-trained models and, well, everything in between.
Their flagship AI platform is Amazon SageMaker, right? What makes it stand out?
SageMaker is incredibly comprehensive. It covers like the entire machine learning workflow. You know, data prep, model training, deployment, monitoring. One of the most impressive features is autopilot, which can actually automatically build, train, and tune models for you.
So it's AI building AI. That's getting pretty meta, but does it actually work?
It's surprisingly effective, yeah. Autopilot can take a data set and automatically like explore different algorithms and hyperparameters to find the best performing model. It's a huge time saver for developers, and it really helps to democratize AI by making it accessible to those who, maybe don't have that deep machine learning expertise.
Interesting. Beyond SageMaker, what else does AWS offer in the AI space?
Well, they have a whole suite of pre-built AI services for things like computer vision, natural language processing, and speech recognition. You've got services like recognition for image analysis, comprehend for text analysis, and transcribe for speech to text, things like that.
So if you need AI that's like ready to go out of the box, AWS has got you covered.
Absolutely. They made it so easy to integrate AI into your applications without having to, build everything from scratch. It's a huge draw for companies that want to like get started with AI quickly. But, some argue that this ease of use can sometimes come at the cost of flexibility and customization.
Interesting point. Okay, that's AWS. What about Google Cloud Platform? They're known for their AI expertise, especially in deep learning.
Yeah, Google's AI strategy is like deeply rooted in their research and infrastructure. I mean, they created TensorFlow, one of the most popular machine learning frameworks, and their cloud is like specifically optimized for running TensorFlow workloads.
And of course, there's the famous TPUs.
Right, the TPUs, those are custom designed chips specifically built for the matrix multiplication operations that are at the heart of deep learning. They've enabled so many breakthroughs in areas like, natural language processing and computer vision. They're really in a league of their own when it comes to performance for large-scale AI models.
So for cutting-edge research, Google Cloud has a clear advantage.
I'd say they're definitely a strong contender in that space, yeah. They also have Vertex AI, their unified machine learning platform, which aims to like simplify that whole machine learning workflow, similar to SageMaker.
Do they also offer pre-built AI services like AWS?
Yes, they do. Their Cloud Vision API and Natural Language API are very well regarded, for their accuracy and performance. They're built on some of Google's most advanced AI models, and you can integrate them into applications with like just a few lines of code.
So it seems like Google Cloud caters to both the hardcore AI researchers and the developers who want to use pre-built AI components. Now, let's move on to Microsoft Azure. They're the enterprise cloud giant, right? How does their AI strategy differ from AWS and Google?
Well, Microsoft has a very strong focus on enterprise integration. They're known for making their technology very accessible to a wider range of users, even those without a like super deep technical background.
I've heard good things about Azure Machine Learning. How does it stack up against SageMaker and Vertex AI?
Azure Machine Learning is a very capable platform for sure. It covers that whole machine learning life cycle, and it has a particular strength in MLOps. They have a really strong focus on making it easy to manage that whole process, from development to deployment and monitoring.
What about their pre-built AI services?
They offer a wide range of cognitive services, which are designed to be like easily integrated into existing business applications. They cover things like vision, language, speech, and decision making. Allows businesses to add AI capabilities to their products and services without having to, build it all from scratch.
So it's AI for the business world, tailored for like real world problems. But with so much focus on ease of use, does that mean they sacrifice power or flexibility?
That's a valid question. Some argue that Microsoft's focus on accessibility means their platform might not be as well suited for cutting edge research as Google Cloud or AWS. However, their enterprise grade security and compliance features are a big draw for many businesses.
That brings up an interesting point. Are there any major differences in security and compliance between these platforms?
All three providers take security very seriously. They offer robust encryption, access control, compliance certifications. But Microsoft, with their long history in the enterprise software world, might have a slight edge in perception when it comes to security, especially for those highly regulated industries.
Okay, we've covered the big three. What about IBM Cloud? They're often seen as like the underdog in this whole cloud race. What's their AI play?
Well, IBM is taking a more focused approach. They're targeting specific industries and use cases with their Watson AI platform. They've actually been in the AI game for a very long time and have a strong reputation in areas like natural language processing and conversational AI.
Watson, as in the Jeopardy playing supercomputer.
That's the one. Yeah. They've taken that core AI technology and built a suite of services around it, targeting industries like healthcare, finance, retail.
So they're going for depth over breadth, focusing on areas where they have a clear advantage.
Exactly. They're not trying to be everything to everyone. They're leveraging their expertise in specific domains to provide, those tailored solutions.
This all sounds incredibly complex. Choosing the right cloud AI platform is like a big decision. What are some key things to keep in mind when making that choice?
First, you really need to understand your workload. What kind of AI applications are you building? Do you need like those cutting edge deep learning capabilities? Or are you more focused on using pre-built AI services? That'll help narrow down your options.
That makes sense. What else should we be considering?
Well, you should think about your team's expertise. Are you like a team of experienced data scientists or just starting out with AI? Some platforms are definitely more developer friendly than others. And of course, budget is always a consideration. Cloud AI can get expensive, so you need to carefully evaluate the pricing models of different providers and choose one that aligns with your financial resources.
It seems like there's no like one size fits all answer.
You're absolutely right. The best platform for you will really depend on your specific needs, technical expertise, budget, and long-term goals. It's like, choosing the foundation for your house. You got to make sure it's the right fit for what you're trying to build.
This has been a fantastic overview of the major cloud AI platforms. We've seen how each provider brings, their own strengths and weaknesses to the table. But what's next? Where do we go from here?
Well, now we've kind of explored the landscape of current cloud AI offerings. I think it's time to step into the future.
Emerging trends, you say. This is where things get really exciting. Welcome back to the deep dive. We've explored how AI and cloud computing have become like this unstoppable force in the enterprise tech world, and we even dove into how the major cloud providers are shaping the current AI landscape.
Yeah, we've covered a lot, but now it's time to, look beyond the horizon to the emerging trends that are going to define the next decade of AI.
Right, we're talking edge computing, serverless AI, even the mind-bending potential of quantum computing.
These are the technologies that are going to push the boundaries of what's even possible with AI, and they're all happening in the cloud.
Let's start with edge computing. I keep hearing this term everywhere these days. What is it exactly? And why is it such a game changer for AI?
Well, imagine a world where AI isn't confined to those, massive data centers. Instead, it's distributed, operating right at the edge where the data is actually generated.
So instead of sending all that data to the cloud for processing, the AI is doing its work locally. Why is that so important?
It's all about speed and responsiveness. Think about a self-driving car. It needs to make split-second decisions based on like real-time data from its sensors. Sending that data to the cloud, that would introduce way too much delay. But with edge computing, the AI can analyze the data right there in the car, allowing for instant reactions. And in that scenario, that's critical.
So it's not just speed, it's also about bringing AI to places where the cloud might not reach.
Absolutely. Think about like remote areas with limited connectivity, or even, spacecraft exploring our solar system. Edge computing lets AI operate in these environments where relying on constant communication with the cloud just wouldn't be feasible.
Wow, this is blowing my mind. What are some other real-world applications where this edge AI could be like transformative?
Oh, the possibilities are endless. Think about smart factories where AI-powered robots can monitor production lines in real time, detecting and correcting errors before they even happen. Or hospitals where AI could analyze medical images right there, at the patient's bedside, providing like instant diagnoses. Or even retail stores where AI personalizes the shopping experience based on your movements and preferences.
It sounds like edge computing is going to bring AI into practically every aspect of our lives.
It has the potential to do just that. And cloud providers are definitely recognizing this. They're developing like hybrid architectures that blend cloud and edge computing. This gives you the power to manage and deploy AI models across both environments.
Okay, so edge computing is all about bringing AI closer to the data. What about serverless AI? That sounds almost like too good to be true. AI without servers.
Well, I mean, the servers are still there, but serverless AI is about abstracting away the complexity of managing them. You, as the developer, get to just focus on your code, your models, and your data without having to worry about, all that underlying infrastructure.
So the cloud provider handles all the details of provisioning servers, scaling resources, and keeping everything running.
Exactly. It's like having this like invisible team of IT experts working behind the scenes, making sure your AI has all the resources it needs without you having to lift a finger.
I can definitely see how that would be appealing to developers. What are some of the other advantages of this approach?
Well, it can be incredibly cost effective because you only pay for the computing resources you actually use. It's also perfect for applications that have, like, variable workloads or unpredictable traffic patterns. The cloud automatically scales up and down based on your needs, so you don't need to over-provision servers just in case there's, like, a sudden spike in demand.
Are all the major cloud providers offering these serverless AI platforms?
They are. AWS has Lambda, Google has Cloud Functions, and Azure has Functions. And they're constantly, evolving and adding new features to support even more sophisticated AI workloads.
It sounds like serverless AI could be a game changer for like smaller companies or startups that just don't have the resources to manage their own, complex infrastructure.
Absolutely. It really democratizes access to AI, making it easier for, well, really for anyone to build and deploy those AI-powered applications.
Okay, so we've talked about edge computing bringing AI closer to the data and serverless AI taking care of all the infrastructure headaches. Now for the really mind-bending stuff, quantum computing.
This is where things get really interesting and, maybe a bit speculative. Quantum computing is still in its very early stages, but it has the potential to completely revolutionize AI. And of course, the cloud is right at the forefront of this revolution, with providers starting to offer like early access to quantum computing services.
I have to admit, I'm a little fuzzy on how quantum computing actually works. Can you give us a crash course?
Sure, it's based on the principles of quantum mechanics that governs the behavior of matter, at the atomic and subatomic level. Instead of bits, which could be either a 0 or a 1, quantum computers use these things called qubits, which can be in a superposition of states, meaning they can be both 0 and 1 simultaneously.
Okay, my brain is already starting to hurt. Why is this such a big deal for AI?
Because this weird property of qubits allows quantum computers to perform certain types of calculations exponentially faster than traditional computers. And, that's a game changer for AI, especially in areas like optimization, simulation, and machine learning.
Can you give us some like concrete examples of how this quantum computing could impact AI?
Imagine training those incredibly complex AI models in a fraction of the time it takes today, or simulating complex systems like the human brain or financial markets with just unprecedented accuracy, or even developing entirely new types of AI algorithms that are impossible to run on, our classical computers.
It sounds like something out of science fiction, but you're saying this is actually happening. Are we going to have quantum-powered AI running in the cloud anytime soon?
Well, it's still early days, and there are definitely many technical challenges to overcome. But the progress is remarkable. Cloud providers are investing a ton in quantum computing, and we're already starting to see, the first quantum computing services becoming available.
So it's not just theoretical anymore, it's actually becoming a reality.
Exactly. And while it might be a while before we see, like, widespread adoption of quantum AI, it's definitely something that every AI practitioner should be aware of. It has the potential to change everything.
This has been an incredible journey through the world of cloud AI, from the practical realities of today to the mind-blowing possibilities of the future.
Yeah, it's a field that's constantly evolving, pushing those boundaries of what's possible. And the cloud is right at the heart of it all, providing the infrastructure, the services, and the accessibility that's driving this revolution forward.
So, as we wrap up our deep dive into cloud AI, what's the key takeaway for our listeners? What should they be thinking about as they, navigate this ever-changing landscape?
I think the biggest thing is to stay curious, stay informed, and stay adaptable. The cloud AI world is moving fast, and what's cutting edge today might be obsolete tomorrow. Embrace the change, learn new skills, and be willing to experiment.
That's great advice. And one thing's for sure, this convergence of AI and cloud computing is going to continue to shape the world in some really profound ways. Thanks for joining us on this deep dive into cloud AI.